All right, welcome. I want you to get ready to flip pretty much everything you thought you knew about math completely on its head. We're going to dive into a pretty wild idea today. What if the fundamental constants of the universe, things like pi, aren't just fixed values, but are actually lines of code in some kind of cosmic program?
So let's just jump right in with a single, kind of disorienting question. What if a number wasn't a thing? A noun, like a rock or a tree. What if it was actually an action, a verb? Think about it. What if the number 5 didn't just represent a quantity, but was an actual instruction to do something?
Okay, so before we get into the really mind-bending stuff, let's ground ourselves for a second. Let's just quickly talk about how we normally think about math. In the world we all live in, numbers and constants are just things. They're static, they're reliable, they just don't change.
I mean, in the math we all learned in school, right? A constant is just a fact. Pi is always pi. If you write x equals 5, you're really just sticking a label on a quantity. It's a now. And the key thing here is that it's totally inert. It just sits there. It doesn't do anything.
And this is such a great metaphor for the limits of that traditional view. A constant is like the picture on the front of a jigsaw puzzle box. Sure, it shows you what the final image is supposed to be, but it gives you zero information, absolutely none, about how any of the individual pieces actually interlock and fit together.
All right, now let's take that whole idea and just completely flip it on its head. We're about to introduce a new core rule, a new axiom, a really fundamental shift in how we might see reality. And believe me, this is where things start to get really, really interesting.
So here it is, this central claim. What if the universe doesn't store a big list of values, like a giant spreadsheet of facts? What if, instead, the only thing it stores are the records of things that have happened, the execution traces, kind of like the digital footprints left behind by a computer program? In this worldview, everything we see, everything that exists, is just the output of a process that already ran. And you can see just how fundamental this shift in perspective is. We go from thinking about static values to dynamic execution traces, the actual history of what happened. Nouns become verbs. An index, a simple label, becomes a method. It's no longer just a pointer to a value. It is the set of instructions that you can run.
Okay, I know this looks a little dense at first glance, but let's just walk through it. Think of this as a kind of hierarchy of being. At the very top, you have reason, the pure structural necessity for something to exist. That reason gives birth to a constant, which isn't a dead value, but a frozen witness to that necessity. That constant then unpacks into a method, an entire family of executable instructions. When you run that method, you get a witness, the computed output. And finally, when you measure that output, it collapses into an index. It's a flow from pure logic all the way down to a simple number.
All right, I know that was all pretty abstract. So let's bring this down to earth with a really concrete example, one you've probably heard of, the SHA-256 algorithm. Yeah, the one that's at the heart of things like Bitcoin.
Now, in this new way of thinking, SHA-256 is not a hash function. Let's just get that out of the way. It is a virtual machine, a tiny, self-contained computer. And those weird, seemingly random constants inside the algorithm, that's not data, that's the machine's firmware. And the final hash that it spits out at the end, that's the execution trace. It's a perfect record of the program that just finished running.
I mean, just look at this. When you lay it out, the architecture of this math function is staring you right in the face. It's got registers for memory, it's got ROM, which holds the firmware, those K constants, it has an ALU with opcodes, a set of core instructions, it even has a clock that runs for 64 cycles. These aren't just features of an algorithm, this is literally the blueprint for a microprocessor. There's a tiny, complete computer hiding in plain sight inside this math function. And this is where it all clicks. That first so-called constant, K0, that hexadecimal number, it's not just a value to be mixed in. No, in this new view, that number is the instruction. It's the opcode that tells the virtual machine what to do, in this case, perform an add operation. The number isn't just data, it's an action to be performed. The value is the verb. So, if all of these constants are really just instructions, that begs a pretty big question, right? Is there a primary instruction, a first verb that kicks everything else off? Well, this framework proposes that yes, there is, and it's called H, the universal attractor. And there it is. The proposal is that H, this most fundamental instruction,
is simply pi divided by 9, which is about 0.349. Now you're probably thinking, okay, why that specific number? Well, the core idea here is that this specific ratio represents a kind of perfect equilibrium point, a universal sweet spot that allows a system to achieve stable complexity.
You can think of H as a kind of universal governor, or a fixed point. It's like a cosmic tuning knob. If a system's value dips too far below H, it just stagnates and freezes into a dead, unchanging state. If you crank it too high, it explodes into pure, useless chaos. But right at H, that's the magic spot. That's where you get the maximum information capacity per cycle. It's the point of perfect balance. And this theory suggests it's the hidden reason that complex, stable things, like us, can exist at all. Okay, so this is a really fascinating, mind-bending idea, but so what? Why does any of this matter? What's the real payoff for this huge conceptual flip? Well, the payoff is that mathematics stops being a silent, passive tool, and it starts talking back. It actually starts giving us useful feedback. And this is where the whole meaning of failure, of getting something wrong, completely changes. In old-school math, a wrong answer is just a dead end. It's a contradiction, and that's it. But in this new math, a wrong answer isn't a failure. It's a debug signal. It doesn't just tell you that you're wrong, it gives you the reason why you're wrong. So instead of just getting a generic error message, imagine math telling you things like, hey, this theorem can't fire because you only have one witness. Or, that lift is illegal because the bookkeeping double-counted something. Or even, this runtime just died because the hold state collapsed before the commit. See what's happening? Suddenly, every mistake becomes a useful clue. We go from mystery and contradiction straight to provenance and reason. It turns math into an engineering problem. And that, of course, leaves us with one final and pretty massive question to think about. If we really go along with this, if constants are instructions, if numbers are little programs, and if reality itself is just an execution trace, well, that leads us to the biggest question of all, doesn't it? If the universe is a computer, what program is it running?